Today is September 8th. So the last class we just barely started distance, finding the distance between 2 points on a coordinate plane. So this is going to probably be a little bit longer. I'm doing practice problems mainly in this video, but I'm also going to put the rest of that lesson in here. So I think I already pointed you toward old lessons you can look at. If you watch the last video I did, I don't even remember the name of it, but I know I show in that recording, I show two old videos that you can watch that go through finding the distance between 2 points on a graph, finding perimeter on a graph, finding area on a graph. So you already have that, but I'm going to give you kind of that same lesson again. It'll be a much shorter version probably. So you should have plenty of resources, and then I'll do the problems in this as well. So with that in mind, let's go to the problems first that we've already done. So this is for your quiz on September 10th. So it's going to be on complementary, supplementary angles, creating a word or an equation from a word problem, also solving out a problem, and then finding the distance between 2 points on a graph, area, and perimeter of 2D shapes, two-dimensional shapes that are on a graph. So here's what we kind of did. I'm not going to review the lesson on most of this. We talked about some different concepts and angles. That's what we did in class for the assignment. I'll show that. I mean, it's recorded, so you can go back and look at it. We talked about complementary and supplementary. So this example 2 right here, let's see if I can, there we go. So this example 2 right here, that's definitely something you need to know. I'm going to give you a picture that's easier. It's not going to have all of that stuff in the background, that whatever that called, that tangram thing. I'm just going to give you something that looks more like that. And if the two lines are perpendicular, that means we have right angles. That would be a right angle. That would be a right angle, we said. That would be a right angle. So all four of these would be right angles. And then that's what allows you to then set some of the equations up. 90-degree angle means if we split that angle into two angles, little plus little is big. Those two little angles we just created would have to add together to be 90. That's a super fast review. Let's see. I'm not going to do, we did that in class, example 2, if you want to go back and watch the video from last week. It was probably Friday, I think we did that, and we started distance. So I'm just going to go straight to the problems. We've already done some of these. That's now recorded, what you're seeing on the screen. I don't know if it's going to stay when I delete or not. Oh, it did mostly stay. So I'm kind of surprised that all of that stays. So I'm going to get rid of, I don't really know why, to tell you the truth, I don't know why I wanted to save that, but I'm going to get rid of it now. And we're just going to go, I'm going to zoom way in. We're going to do some problems. We'll see how far I am. This is on page, don't worry about the pages I have listed here, although that one might be correct there. The problems are on page 77. It's not in the 80s. I got that wrong when I typed it in, so I just haven't changed it. Yeah, so this is page 77, not page 87. I will at least change that. Oh, I can't change that. All right, well, let's do it this way. I mean, I can, but it'll take a minute. So I'm just gonna do that. 77 are these practice problems. So I signed 1 through 24, but I then said there were some specific ones you really needed to make sure you knew how to do. And do I have those written down? I do not. So I'll put them in the video. I said 1 through 5. And again, this is recorded from the lesson in class. So you definitely need to know how to do 1 through 5. That's these word problems I'm about to go through. You needed to know how to do number 9. That has to do with complementary angles and perpendicular lines. And then I believe it was 17 through 19. Again, it's recorded from the last class, but I'm pretty sure those are the main ones. And that doesn't mean and then this was half of your quiz, and then I'll show you the next topic that'll be the rest of your quiz in a second. So let's go in and we're going to look at number 2. I expect you to know how to do, so I'm not going to specifically do number 2. That one is not difficult at all, in my opinion. I will give you a hint on number 2, and I'm actually going to get rid of add more room. On number 2, it says angle E and angle F, and sometimes that can make it a little trickier when they're using the angle symbol and the name of the angle. It is fine for you to just say, well, I'm going to make angle E X and angle F Y. That's fine. Even if you don't later change it back, I'm fine with that. Just make sure when you solve for the correct angle. So if they said, what is the measure of angle E? You need to tell me the measure of angle E. And here they don't really do that. Like if you'll notice, they just say find each angle, so it wouldn't even be a problem. You just give me the 2 correct angles and you're fine. I don't even care if you label them correctly. Just know they may ask you specifically for one angle, and you need to know which angle is which measure. I'm going to skip down to number 3. So number 3, you have it in your book, or now you can write it down, pause it, whatever you do, because I need to make some room. It says the measure of an angle's supplement. So again, we talked about circling numbers. So there's 76. Actually, tell you what, let me do this in highlighter so we can hopefully still see through. So 76 is a number. Let's see. Well, it doesn't give us any other numbers. So this is one where you're going to have to know some concepts in order to find what the other numbers are that you need. So that will come into play when we do the boxing. So next, I'm going to box important words. You could say measure is important or angle is important, but the real one, actually, tell you what, I'm just going to highlight it instead of boxing it. That word right there, extremely important. Those 2 words, extremely important. And then again, supplement appears again. So we said this in class, maybe not in every class, so I'll say it again. Another way to say that 2 angles are supplementary is just to say one angle is a supplement to another angle. So when you see that word supplement, it just means supplementary. It's not anything new or different from supplementary. So that means you have 2 angles that what? So pause it, try to remember, look it up if you need to, don't just wait. And I know most of you just waited. 2 angles add up to 180 degrees. We talked in class how to remember, but alphabetically, C comes first. Numerically, 90 comes first. Then that means supplement would have to be 180. So if I want to convert this to a word problem, I already have to make that connection that 2 angles are supplementary. I need to know the definition of that. That means they add up to 180 degrees. So if I'm saying 2 angles add up to 180 degrees, that's one of my equations right there. So I'm going to just call them again angle, or not angle, but I'm just going to say X and Y are the 2 angles, which is fine. I don't care. You don't have to use an angle symbol unless they tell you to for some reason. So that's one of the equations. You'll find a lot of times X plus Y is a part of an equation, and you just have to know what that's supposed to equal. Now I got to kind of figure this other part. So we talked, I'm gonna get rid of some of this so I can kind of walk through. We talked in class how a lot of times you just read through the question or the problem or the information or whatever and convert it to numbers. Oh, we didn't box a very important word. Is very important word. I don't know why it's not highlighting that better. Huh. Ah, it shut down. Man, I don't know what is going on with this smart notebook, but it shuts down all the time. All right, it'll only take a second, hopefully, to get started back up. So again, I'll keep talking about that. Is an extremely important word when it comes to word problems, whether it's about angles or not. 9 out of 10 times, so almost all the time, is will convert directly into an equal sign. The way you can sort of test that just to make sure it works is just change the word is in the word problem to the word equals. And if that sentence still makes sense, I guess I would. Let's see what happens. So if that sentence still makes sense, I really hope they save some of that. If that sentence still makes sense, oh, this is actually an old one, so yeah, it'll also be in there. Oh, God dang it. All right, hold on. I gotta go back through. I mean, again, you can go back and rewind. I'm not redoing any of that. Oh, right there are the problems you need to know how to do as well. So just kind of catching you up. I'm not going to zoom in or anything. I don't know if that has something to do with why it crashes. So we did say x plus y equals 180. That was one of our, what is wrong with this? That's one of our equations because they are supplementary. One angle is the supplement to the other. I guess I ended up doing at least a little bit. Now we can just read pretty much straight through. I keep saving it so that if it does crash, we can come right back. If we just read straight through that sentence, it will normally tell us exactly what to convert. So again, I'm doing number 3 if you don't remember. So it says an angles supplement. Now that I know that's confusing, but let's just skip straight to this part. Is 76 equals 76. I mean, that's going to be, oh, actually, that's not going to be part of it in this one. We are going to have equals there. So this first part, and you'll just have to do some problems practices. If it says an angle sept, all it's doing is it's just talking about an angle right there. It's just saying, hey, one of the angles. So it doesn't tell us which one, bigger, smaller. So we just write one of the angles. Then we do convert is into an equal sign. So that is still right. But here's the tricky part, sort of tricky. When we talked about this in class. If it says is less than, I can't write 76 first. So there's the example I did in class. If I have $5 less than you have, we don't say 5 subtract what you have, right? So if you have $10, we don't say 5 subtract 10. That would be -5. We have to start with what you have. So if it says less than, and I did a thing in class on this, I'm not going to redo the whole thing. We have to say the other angle is what we start with, and we subtract 76 from that. Because again, this angle X is less than, it needs to be lower than the Y, the other angle. So I need to subtract 76 from that. So you got to put a little thought into which angle would be smaller than the other one. So X is less than Y. So therefore I must need to subtract 76 from Y. That's one of the trickier things, less than for sure. More than is not easy. You can start with a number and just add the angle from there. So those are normally easier. So that's my 2 equations right there. You should definitely get one. That one's not super difficult. As long as you understand supplement just means supplementary. So I'm not going to solve this out. The algebra is up to you. We would, actually, yes, I am. Just this one. We did it in class. We did it a bunch in class. If I know X is equal to all of that, I can get rid of that X and replace it with that because they're the same. I'm giving you the short version. So I would say Y subtract 76. So again, I just replaced the X with Y subtract 76 because they're the same thing, plus another Y equals 180. That's just the rest of the equation. So that's just this part of the equation right there. So 2y, I would add 76 to both sides. So I'm going to just go ahead and do a shortcut. You need to practice algebra. So y would equal 128. Now I need to find x, and I have a couple different ways. If I know they're supplementary, I can just say, okay, well, if they're supplementary, x would just be 180 subtract 126. I'm sorry, 128. Or I could say, well, I also know right here, I'm going to highlight it. X is equal to y subtract 76. So I could do that as well. And I could say, all right, well, x equals y, which I now know is 128, 128, subtract 76. And you better get the same answer. X can't have two different measures. It's the same angle. We just did the math two different ways. So I'd get 52 over here. And if I subtract over here, I also get 52. So remember, plugging the x in is the tricky part, especially if you don't have x all by itself already, which we do in this problem. Like right here, x is already all by itself, so it's easy to substitute. If it's not, then you have to do that process of getting x by itself. You can watch the video that we did on Friday from that. So that's on your quiz. So this problem right here, I said you needed to know how to do for sure. It already has, I'm gonna get rid of all this stuff. It already has, I don't think I can, whoopsies. Let me see if I cannot zoom in anymore. Yeah, that's as much as I can zoom so you can look in your book. It already has a drawing, that's why I said you need to know that one. Why is it doing that? Let's do this. So that's the one that I said was important. If you read through the information, I would go to the picture and try to put it in the picture. So it says this right here. First of all, we went over that in class. That symbol, you need to know that symbol means perpendicular. That's, why is it doing that when it's on the pin? There. That symbol means perpendicular. It kind of looks like it's perpendicular, right? Like we have right angles, and we do. So that's the symbol for perpendicular lines. So it's telling us I would guess blue is fine. It's telling us that HL, so again, I'm back down there, HL is perpendicular to HJ. It actually in the figure also tells us that. If you notice, it gives us a right angle right there in that little section of that angle. So it kind of tells us that in two ways. It may not give you both though, so just know you need to understand what both of those things mean. So next, now if I know that's a right angle, then my first thought needs to be, okay, that's 90 degrees. That right there is 90 degrees, that whole angle there. Well, now if all I do is I take that angle and I split it with that ray, or you could say line, it's really a ray. If I split that, it's still 90 degrees from there to there. I did not change those blue lines. So hopefully you're thinking to yourself, actually pause and try to figure out what concept we're talking about. I'm going to go ahead and start. Hopefully you did that. If not, hit pause quickly. If I just split that, angle 2 and angle 3 make up that blue angle now. Well, if the blue angle is 90, then angle 2 plus angle 3 have to equal 90. I just split the 90 into two angles. Angle 1 is just extra information. Angle 4 is just extra information in this problem. Yeah, I was going to say you might use it for some of the other questions, but it doesn't look like any of the other questions use this figure. Now, what I do want you to understand is something else in the figure, which isn't part of this problem. 1, 2, and 3 have something special as well. So I want you to think about what's true about 1, 2, and 3. Angle 1, angle 2, and angle 1, angle 2, angle 3, and angle 4. And then I want you to think about, well, what's got to be special about angle 1 and angle 4? So think about that, pause it. I'm going to keep going. So if this is a straight line, which it is, we would just assume it. That's probably going to mess up. Oh, no, I didn't. If that is a straight line, that means that is 180 degrees. That means angle 1 plus angle 2 plus angle 3 plus angle 4 has to equal 180 degrees. Well, if I know that angle 2 and angle 3 have to add up to 90, that means angle 1 plus angle 4 would have to add up to 90. So that's a little bit higher level thinking than the other, well, definitely than the other problem, but I'm not even going to put anything that difficult on my quiz. But that's the kind of stuff you will see on the district stuff or the EOC. You need to make all of those connections and then be able to solve out the problem, which we're going to just do now. Okay, so it tells me in here, now that I know that angle 2 plus angle 3 has to be 90. Well, that's the measure of angle 2. That's the measure of angle 3. So I would just say A plus 15 plus A plus 35. And A is just a variable. We're just using that as a variable. Has to equal 90. So doing your combining like terms, we have two A's there, so that'll be 2A. We have two numbers there, so we'll just add those. So what was that? 2A plus 50 equals 90. What's going on with my screen here? So I subtract, you should try to solve this on your own. I should have told you to do that. I'm hoping you have this down by now, but I know some of us are still working on that. So 40 equals 2A. So go ahead and do the last step at least. A equals 20. Now, in this case, we do not have to go back and solve for angle JHK or angle KHL. But I will tell you right now, a lot of you missed points on the quiz. I just finished grading the angles quiz because you did not read the question after you solved for the variable. I believe, well, the first two questions, not all of the questions. The first two questions wanted you to solve for the angle. A lot of you set the equation up correctly for number one. Some of you, I don't remember how many, solved for the variable correctly, the x, but you did not go back and plug it in. So unfortunately, you lost a lot of points on that. You have got to get in the habit of reading the question after you solve this. All right, so next, let's go to let's see, 7. Oh, I need to hold on. I forgot I kind of slid things around. There we go. So here we go. Refer to figure on the right. So it wants to make ADC. So if you read all that information, I'm doing number 17. If ADB is that, so again, they're giving you the measure of an angle. That's what that is. They're giving you the measure of another angle. That's the measure. Doesn't matter that there's X's and pluses and all that. That's the measure of those angles. So if you want to write them into the image, I'm not going to because I can't really zoom in anymore. I wish I could. Yeah, I can't. I've already tried, but just in case. Yeah, I can't. Oh, wow. Now it let me zoom in. I don't understand why now it let me zoom in, but all right, if that's the case. Now can I see all of it at once? So BDC is 4x plus 24. So I'll go ahead and write that in. So 4x plus 24. And then I'm going to write degrees, just so you understand that's just the measure of the angle. Now, so ADB is 6x subtract 4. So ADB, which would be, again, you have to know what I'm talking about when I say the name of an angle and when they say the name of an angle. You're just following the letters, A to D to B. That's the angle right there. And remember, we measure the angle way down in here. So it doesn't matter how big the angle looks out at the ends out here. Like none of this matters out here. We measure the angle down in the little corner. So that angle is, I think it was 6x subtract 4. Now I forgot. I'll go back and look, but I'm pretty sure it said 6x subtract 4. Let's see. So I'm going to do what you'll see sometimes. That angle right there, that little angle is 6x subtract 4. You'll see that in the books where they'll put a little arrow pointing into an angle when they don't have room to try to fit that whole expression inside the angle. Again, an expression is just these things that look like equations sometimes to you guys. So if I know that's the measure of the two angles, let me get rid of this now. And in the very beginning, well, actually, it doesn't tell me perpendicular in this. It actually just says that angle. Actually, which angle does it say it's 90? Hold that. I guess I have to do it this way. ADC, it wants to be a right angle, which it doesn't look like a right angle. So again, this is one where you have to understand things are not always to scale. Like ADC is not even close to a right angle, but they want us to make it. Like what value would X be to make that a 90-degree angle? Well, that just means that these two would have to add up to 90. Again, if that were a 90-degree angle, which is what they want us to make it, if that were 90 degrees, then this angle here plus this angle here would have to equal 90. So that's all they're telling us. And they say it in a weird way, but sometimes the district will do that and the state. So I just set up an equation, 6x. God dang it, why is this not working? So that is one of the angles plus the other angle. Would have to equal 90. So it's kind of like the same concept as me telling you have perpendicular lines or that the angles are complementary and you would just have to know to add them together and set them equal to 90. I'm not going to solve that out. It's already becoming a pretty long video. So again, if they tell you find the value so that two angles are supplementary, you're just going to add them together. That angle plus that angle. And again, regardless of the image or whatever, it doesn't even really matter. It's telling you they need to be supplementary, so they need to add. So those two angles added together would have to equal 180. That would be your equation. I'm going to go ahead and move on. I think we've been going for way longer than I wanted to. We still have to get to the new lesson that you'll get on Monday. All right, so let's zoom out. So we did distance Friday right at the end very quickly. I'm going to kind of quickly review that. And I don't know how much of the new lesson I'll actually do. You'll get it on Monday. What? I'll record it Monday also. Why is that not? Now I can't zoom in. Son of a gun, it's still registering as. I don't understand what's going on with this. Now I can't. It's not changing over to the still on eraser. Oh my goodness, this is just the most frustrating application sometimes. I'm gonna just get off the screen. We don't need that screen anymore. We're on to something else. All right, so we talked about the distance formula, which I don't even see that on here. I'm not sure where those slides are. We don't really need them, but well, now it's not even changing. I don't know what's going on. I'm gonna have to close it and start it over again. Oh, yeah, I think it was in the process of crashing, so that's why it didn't work. Yeah, all right, let's see if this works. So again, I'll just remind you, we talked about the distance formula on a graph, on a coordinate plane. If it's just a line segment, we said distance and length is just subtraction. So you just take the big number, subtract the small number. But we cannot do that when it's on a graph because we have two numbers. We have an X and a Y. So we had to do that distance formula that was on the reference sheet. We had to do that x2 subtract x1 plus y2 subtract y1. And then we took this square root. Oh, and then we squared those. And then we took the square root. There we go. Now so we talked about perimeter, area. These are the formulas you need to know on your own. You do not get these on the reference sheet. You need to know that. You need to know a square is really just a rectangle, but there's a specific way you can also do a square. Those three, you do not get those on the reference sheet. You have to know the formulas for perimeter and area of triangles and rectangles. We did it in class. You can watch that video if you want to go figure that out. So they do not give you any problems where they just find the distance between 2 points. So I'm going to just, I don't think this will take a super long time. I'm not even going to go in and add a graph to it. I'm just going to quickly draw a graph to show you something you could do. So let's say they give you a problem and they just give you X's and Y's. And they just say, I want to know the distance between these 2 points, 1 comma 4 and negative 3 comma negative 6. I just want to know the distance between those two with no graph. You don't need a graph using that formula. I'll give you graph paper in my class, and you should get graph paper on the EOC or for the district. I can give it to you as well. All you got to do is kind of jot it down. You don't have to be perfect. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just to give yourself an idea. And again, if you have graph paper, you can do it on the graph paper perfectly, but it doesn't need to be perfect. So I know 1 comma 4 would be right 1, up 4, 1, 2, 3, 4. So somewhere about there. Actually, let's change this to. So somewhere about there. Why did that not work? Right. So somewhere about there, negative 3, 6 would be 1, 2, 3, 4, 5, 6. So I go left 3 and then down to about there. That would be about where that line is. And then you just kind of draw a line to connect. So again, does not have to be perfect. So here's the way we did it in class. There's that formula. Let's zoom in. There's that formula we said for distance, which is the same thing as the length of a line segment. So distance from this point right here to this point right here is the length of that line segment. They're the same thing. The distance from one point to another point on a graph is the length of that line segment. And the formula was, which you do get on the reference sheet, that's why I don't mind teaching this formula, square root of, I'll probably write over the top of that, but that's fine. Dang it. So we'll talk about what that means if you don't remember. And then y2 subtract y1 and also squared. All right, so a couple things really quickly to remind you. The big thing around all of that, that weird looking symbol thing, this thing right here, that means at the end you need to square root whatever number you come up with underneath that. We said these things right here are squaring. That's squaring some number, which we don't have a number yet, but we will. We have to, don't forget to do that. A lot of kids forget to square. They forget about that too when they start doing the math. These down here, we said were completely different. This is not math. This is just a way to refer to which X and which Y you're talking about. It's kind of like saying, this is my left point, this is my right point. I'm sorry, this is my first point, this is my second point. I do that by thinking left and right, which I'm going to show you. So now, let's go ahead and I'm going to just quickly go through it. This is also recorded in another video, or I point you to old videos where there's like more detail. So this was my -3, -6 point. This was my, what, 1, 4, I said. I always start with the left point as my first point. So I'm going to consider this one down here my first point, which means it has an x1 and a y1. That's all the ones mean. I consider that to be my first point. So this one over here then would have x2, y2. If you label correctly, there are still some mistakes kids make, but I mean, you're way more than halfway there to solving out and getting the distance between those points or the length of that red line. So now I draw that. I'm going to start plugging stuff in. So I just look back at the points I've labeled. X2 is +1. So I write 1, subtract. Subtraction is part of the equation, though, part of the formula. The x1 is -3. I cannot get rid of that negative sign just because I wrote subtraction. Again, they are two separate things. That's one of the biggest mistakes is kids think when they write the subtraction sign, they don't need the negative sign. I am subtracting -3. And then don't forget to square it. That's part of the formula. Plus, and then now I do the same thing with the y's. Y2 is 4. Subtract. Y1 is again -6. And then don't forget you have to square it. Do not square the individual numbers. Don't try to square the like these. Don't try to square these up here, these 1s and 4s. Like you do the subtraction first. This is an order of operations thing. Then when you get those numbers, you will square them. So if you do it in your calculator, you should get 4. Oh, I didn't say this. We should try to estimate the length. So like how long does that red line look? Well, if I know from here to here is a distance of 10, that red line's probably a little longer than that. So maybe about 11, something like that. Just totally guessing. Yeah, I'll get rid of that. So 4, and then again, square. Do not forget the square. Plus, if you do it in your calculator correctly, you get +10, and then squared. I talked in class, if you happen to try to square a negative number on the blue calculators, sometimes you will get a negative number. You need to understand you cannot get a negative number when you square a number, because a negative times a negative is positive. So that's you just need to make sure you understand that is a positive number. I'll show you when we have time, maybe on a block day, why that happens and how you can fix it. But mainly just know squaring a number has to be positive. It's not an issue in this because they're both positive. So I get 16 plus 100. I just squared those. So 4 times 4 is 16. 10 times 10 is 100. That equals 116. And if you thought about it beforehand, there is no way that is correct. That red line cannot be 116 long if I just compared it to this, which I said is about 10. They have to be to scale on a coordinate plane. They can't trick you when they put stuff on a graph, because the squares are to scale. Like the squares are all the same size. So 116 cannot be correct. So you have to remember when you do this, if that can't possibly be correct, I'm missing something. There's a step I'm missing. So remember when we talked about it at the beginning, that whole weird symbol thing is square root. You need to take the square root of 116, which is just a function on your calculator. You wouldn't guess at that. I don't have a calculator, so I am going to guess at it. It's probably going to be like 10.8, maybe somewhere around there. The way you do it on the calculator, the blue calculator, you hit second function. If you don't have a blue calculator, it won't be the same as this. You hit the x squared button, because above that is the square root symbol. And that's all we're doing is getting to that symbol. Then you put the number in and hit equals. So you should get something like 10.8-ish or something like that. If you have a different calculator, if that doesn't work, put the number in first and then try to hit the square root button. You'll have to find wherever that is, depending on your calculator. So depending on the calculator you have, you do it in different order. So that's how we find the distance between 2 points. Again, we did that on Friday, so you kind of already have it. Now we're just going to go to some of the problems that I assigned and I'm going to assign. I guess we can do, we'll probably do that in class. All right, so here are the problems from class. We're going to probably work on some of these, so you may want to keep your book blank so you can redo them over again, because there aren't a ton of practice problems in this lesson, unfortunately. So it should be to the right of this. All right. So it's asking us, and again, it's a little blurry, but you should have either your book or the pages or at least a picture. I think the handout I give you on Monday is going to be these same problems, I believe. Maybe not. They look the same. The numbers might be different. So they want to know, what is the perimeter or circumference? So we talked about that in class. Circumference is really the same thing as perimeter. It's the length of that blue line that I just drew. It's like, how long is that line? They call it circumference instead of perimeter when it's a circle, though. So that's the perimeter. The blue lines added together would be the perimeter of that rectangle. Again, blue lines added together. So it's basically for triangles, rectangles, any polygon, which we'll talk about later in the year. It's just the length of all the sides added up. That's all it is for perimeter. Now, area has its own formula. You get the formula for the area of a circle. Area of a circle is, and you might sort of remember it when I say it, that's the area of a circle. You also get the formula for circumference, which is kind of like the perimeter. That is 2 times pi times r, or it's also, I can't write it there, diameter times pi. So we'll talk about that more in class, because the diameter is 2 times the radius. So that's why either of those formulas works. Get rid of all of it. You can rewind if you need to go back and look at that. So starting with perimeter. So for perimeter, we just need to know the length of all three sides. Well, this side and this side is pretty easy. Those we can just subtract. That is a situation where subtraction will give you the correct value. Just make sure you subtract the correct number. This is left to right. So that means I use the x values because the x-axis goes left to right. So I just take the biggest number, which will always be the farthest right, because this is going to the right. The x numbers are getting bigger. So 4 is my biggest x number. Subtract 0 means the length of that is 4. Now, there's a much easier way if you're not sure. Just count the squares. 1, 2, 3, 4. Sometimes I say count the hops. Start at this and go 1, 2, 3, 4. I could do the same thing for the vertical one. 1, 2, 3, 4, 5, 6, 7, 8. Or I could count the squares. Or since the y values get bigger going up, the biggest y value is going to be the 9. So 9 subtract. Oops, I'm using the wrong points. I'm sorry. We're using this point down here. So 9 is the biggest value. Subtract 1 gives me 8. So the 1 is coming from that point down there. I was still using this point over here where we were finding the value left in it. Regardless, you just need to find the length of those sides. If you just want to count them, you can count them. That's fine. Here's the somewhat tricky one. We just did it. This right here is the point I need to use with that point. I need to find the length of that line, so the distance between those 2 points. So you can do it with that same formula we just did. So if you haven't written it down yet, write it down. X2 subtract, oops. X2 subtract X1 squared plus Y2 subtract Y1 squared. Again, square them individually. And then take the square root. I'm going to remind you of another way that works. And this way is much faster. And we have a lot of lessons that deal with finding the distance between 2 points on a graph, or just with finding this missing side of a figure where this will work. If I know, let's erase some of this. If I know that I have those 2 sides that we just talked about, I know that was 4 up here. That's how I just calculated it, or I counted it. And if I know this one here is 8. Anytime you have a coordinate plane, you can draw a right triangle in. This one's already a right triangle. So I have a right triangle. Well, we talked briefly about it in some of the classes. The length of the sides of a right triangle have a special relationship. It's the whole Pythagorean theorem thing, but most of you just remember this. If you take one of the small sides, which they're called legs, and you square it, and you add it to the other shorter side, and you square both of them, they have to add up to the longest side, which is called the hypotenuse, squared. So we're going to do this in class on Monday. We haven't done it yet. This is new. So I can actually solve for this side by using that a squared, b squared, c squared thing. Or I can just plug it into the distance formula. I'm going to do it both ways really quickly, and you'll see that it comes out to be the same. So if I do Pythagorean theorem, my 2 short sides are the 8 and 4. It'll always be numbers that are going straight up and down, or sides that are going straight up and down, straight left and right. Because we're always going to be solving for the diagonal one because we can't count that one. So 8 squared, I'm going to do it up here, plus 4. I don't know why this is so weird. 8 squared, don't forget to square it. 4 squared has to equal c squared. That's the one I'm trying to find, the diagonal one. That's a 2 if you can't see it. God, man, my screen is not writing. Or if I need to open it up more. So there we go. 8 squared plus 4 squared equals c squared. You cannot do this without multiplying it all out and taking the square root. So sometimes kids try to find a weird way to do it, but so this is 64 plus 16. And again, it's a good idea to estimate. If I know the left side is 8, that vertical side is 8. This side's probably maybe like 9-ish, something like that. 9-ish, somewhere around 9. So that'll help me know when I maybe haven't finished. Like, for example, that comes out to be 80. Well, clearly that is not about 9. So I haven't done something. I'm missing something. I don't want to do it that way. Hold on. That's 80 there. I'm gonna add it up there. So on this side over here, I still have c squared. Right, because I haven't done anything on the right. So 80 equals c squared. So the sides are side A, B, and C. So we don't want c squared. We just want c. That'll be the length of c will be just c. So I need to take the square root of both sides. Taking the square root of 80 will give me almost 9. I don't have a calculator, so 8.9 something. Taking the square root, if you take the square root, so again, this goes back to algebra, the square root of c squared is just c. Hey, there. So that gets me down to just c, and that's what I want. So now I know this side over here. Again, I don't have a calculator. If you want to do it and get the exact number, you can. I don't care where you round. Just you would need to show me. Oops. This is what I'm mainly looking for right there when I grade. So if that is, we'll just say 8.9. I want to know perimeter. First of all, I just add all those together. So that's 12 plus 8.9. So you can do that in a calculator. Now for area, you have to know. You can go back and rewind if you need to, because I need some more space. You have to know the formula for the area of a triangle. That is not something I'm supposed to have to teach. So the area of a triangle is 1/2 times the base times the height. That's the area of a triangle. And they want the area of a triangle here. So I take the base and the height are typically going to be the vertical and horizontal lines. So the 8 and the 4. Oh, I don't need to know the 8.9 for area, just for perimeter. So I take 1/2 times 8 times 4. So the area of the triangle would be 32 times 1/2, or 32 divided by 2. So that's the area of that triangle. All right, so now we're gonna, and again, I could have plugged all that in. I guess maybe I'll do it quickly. I'm not gonna do this on every problem. If you want to follow the formula way, you can do it. I'm gonna show you really quickly how to do the formula way. Okay, let me see if I can zoom in real quick. Hopefully it doesn't mess it way up. Does not work. Oh, let's see. Yeah, I don't know. I'm already all the way zoomed in, I think. So I don't know why it let me zoom in that other time that normally. So I know I'm gonna start with my farthest left point. 0. I'm just gonna write them so that you can see them better since it's really small. You have it in your book too. So 0, 1 is my farthest left point. I just got it from right there. So that is going to become my first point. That's the way I like to do it. So that is my x1 and my y1. So my second point would be that. Oh, God. So 4, comma 9 will be my x2 and y2. Getting there we go. So now I just plug them in. I'm just going to kind of write over the top of all of this. So I'm going to make the pen even thicker so you can see. So you have the formula. I'm not rewriting it. The formula is take the square root. Oh, it didn't even make that larger, which I don't understand why it doesn't do that sometimes, but it doesn't. Okay, let's see if it works. So x2 is 4. Yeah, it's not working. I just don't get why this is so horrible. It used to be perfect. X1 is 0. I need to square that because that's the formula. Again, you have the formula hopefully written down already on your own. Plus y2 is 9. God, it's driving me crazy that I can't make this thicker line. Y1 is 1. And I square it. So again, you'll see we get the exact same numbers we just used. I'm squaring 4. I'm squaring 8. Don't forget about that. So I would again have the square root of 16 plus 64, which is 80. You get the same thing. I don't care which way you do it. I think that the way where you just say, well, if I know that side is 8 and that side's 4, I think that's much faster than having to say, okay, which one's my x1, my x2, my y1, my y2. But if you just like a process, the formula way works great. So really quickly, I'm going to show you how to do the next one, the hold that thought. I'm going to show you how to do the next one with the triangle method, the a squared, b squared, c squared. If you'll notice, we don't have any triangles. So you actually have to create the triangle you're going to use. I don't know if this is going to work or not. It might still be super, super thick. If I want to find the distance between, yeah, it didn't work great. Fantastic. If I want to find the distance between those 2 points, again, you can just do, I'm not going to keep doing the distance formula. You should hopefully know how to label. I will tell you that. X1, Y1, X2, Y2. Now plug it in. So X2, Y2 would be, it looks like both of them are 4 in that case. Let's try this one more time. So I'm going to try to find from here. Oh, there it worked there. But I'm going to do it with a right triangle. And again, there's not a right triangle created. So I'm just going to draw one. I know that I can create a triangle. The x-axis, or all these grid lines really, they're all perpendicular. So if I just trace the grid lines, I create a right triangle. That's a right triangle. There's the right angle right there. Now I can go ahead and find A and B. Again, they're going to be the sides going left and right and up and down. I can just count. The bottom one is just 2. The one going up is 4 squares, so it's 4. Now I have my A and my B. So it'll be 2 squared plus 4 squared has to equal C squared. I'm going to kind of do it. Actually, I guess I could. God, why is it not working? It's driving me crazy. Very angry. Actually, I don't have a whole lot of room, so I'm going to come. So if I square those, 2 squared is 4, 4 squared is 16. That equals C squared still, remember? So that means 20 is C squared, but I don't want C squared. The sides of a right triangle are A, B, and C. If I have a right triangle, that's a horrible right triangle. The sides are A, B, and C when we do that's just the Pythagorean theorem. So I don't want C squared, I want C, so I need to take the square root of both sides. So C would equal the square root of 20, whatever that would be. Uh, Probably like 4.4, somewhere around there. Something like that. So do it on a calculator and get the exact answer. So once I know that side, so again, I just solved for this side right here, the hypotenuse or the side of that rectangle. So now that I know that's 4.4, so again, don't get confused. The blue 4 is the blue side that's going up and down when I drew in the right triangle. It's the red side I solved for, the hypotenuse. Again, if you're confused by this, just use the distance formula. I labeled them for you a second ago. Just use the distance formula. I now have to go back. I don't need to do so. I guess I'm going to write it inside. So 4.4 is the length of that side, which means 4.4 is also the length of this side over here since it's a rectangle. So this side is also 4.4. Now I need to find the length of this line right here. Well, again, I can draw in lines going straight up and down and straight left and right to create my, guess I'll do blue to create my right triangle. So there's a line going up and down. There's a line going left and right. I can just count the squares. You can do that in your book because it's getting the lines are a little thick. This is 3 over here. 1, 2, 3, if I count those squares. And on the bottom, what is it? It looks like 1, 2, 3, 4, 5, 6. It should be, I believe. Yes, 6. If you need to go back and look at, well, you have your book. You can look at the book and count how long the bottom side of that right triangle is. So if it is a right triangle, and it is, because that's the whole reason I drew it in, was to make a right triangle, I can do A squared, B squared, C squared. I'll just do it all over here, so I have plenty of room this time. And I'm solving for this green line that I drew in. That's the hypotenuse of that right triangle. If you don't get this, I'll show you how to label it and do it the distance formula way after I do this. So I would say, let's make it, I guess we'll stick with green. So 3 squared. 3 is the shortest leg, the shortest side of the right triangle, plus 6 squared. God dang it. C equals C squared. So the green side is C. And again, this formula is just the formula for right triangles. If you don't know where I'm getting it, then don't do it. Do the distance formula way. So if I square that, 9 plus 36 equals C squared, 45. Equals C squared. And then I need C. Plus, I should know 45 can't be the length of that if the bottom side is 6 down here. There's no way that green line is 45. So I need to take the square root of both. And then that would give me C equals, and I don't have a calculator, but what would it be? It'd be 6 point, probably close to 6.7, probably 6.6 something, but it would probably round up to 7. 6.7. So now if I know that green line is 6.7, that means the other side over here is also 6.7. So I have two 6.7s two 4.4s, add all of those up. So also down there as well. So if you add all four of those up, 4.4 plus 4.4 plus 6.7 plus 6.7, that's the perimeter. And then in order to get the area for that, you would just say 4.4 times 6.7. And whatever that equals. I don't have a calculator. So for a circle, it's a little trickier. You have to find the radius. So the radius would be from the very center of the circle, which they're giving you right there. And they would kind of have to give you that. And you would have to find from the center of the circle out. They're not giving you a point right there to do that. They're giving you a point down here, which means, and that would still be the radius. The radius is from the center of a circle to the edge of the circle. It's always the same. So no matter where I draw it, all these black lines are the same. That's how you create a circle, basically. But I would specifically need to solve, I hope this doesn't mess something else up. I would specifically need to solve for that line right there, since that's the 2 points they are giving me. So oh, I forgot. I was going to tell you how to do it. So if you want to know how to solve for this line using the distance method, I would label at least, this would be my x1, y1, because it's just the point to the left. I could reverse this if I wanted. This would be my x2, y2. And now I just plug them into that formula and solve. And you'll see you get the same exact numbers. You'll wind up squaring 6, adding it to 3 squared, and you'll get the same. You should get the same answer. So this might be easy for a lot of you, this problem. It might be easier for you to do the distance formula there. Again, x1, y1 is this point. x2, y2 is this second point. Plug it in, find the length of that line. That is your radius. Then you just follow the formulas for circle, which you do get on the reference sheet. If you wanted to do it the a squared, b squared, c squared way, you can. Your right triangle would go from there to there. Oh, I went too far. That's a length of 2. That's a length of 2 as well, it looks like. Yeah. So again, you would have 2 squared plus 2 squared equals c squared. No matter which way you do it, you better get the same answer. If you work on this at all, or maybe I'll just let you take pictures no matter what on Monday of the answers, because I'm not going to work all of these out. So there's another circle. Squares are pretty easy. Once you find one side, you know that's all 4 sides. So you only have to do it once there. That's an easy side there. You just count. Then, though, you have to either do the distance formula for that side and that side, or make a right triangle. If you're confused about this right triangle thing that I keep drawing in, don't do it that way. Just learn the distance formula. If you understand it, then that would be your right triangle right there. So that side, I'm not sure because I can't see. That side would be 2 up there. So that would be 2. 1, 2, 3, that would be 4. And then you can do the a squared, b squared, c squared. Let's see, what else? So just remember, you need to know the formulas for that and that, area and perimeter. You get them for a circle. You might get problems. I don't do this on the quiz. You might get problems where you don't get a graph. And you have to figure it out. So you could do the distance formula if you wanted. I would still draw a graph out, even if you create your own. Like I said, you can always create a graph real quick and just estimate where the 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, etc. are. All right, so we'll go over this still on Monday. Like you haven't even gotten this lesson. I'm just recording it in case anybody wants to start looking at it early because some people are going to miss Monday due to testing. Yeah. And then we did the video on what is area, what is perimeter last class. So I'm not going to talk anymore about that. So I think that's it.